So in the second half of this section 6, we're going to do two things. We're going to kind of take some data and we're going to write equations based off of it. And then second, we're going to show you how to change from point slope form to standard form, which I already showed you one example earlier, but I want to show you that kind of in an official capacity here. Please recognize this equation, one of the most important simple equations to use. Why is it called point slope? Because what do we use to get it with? A point and a slope. Now, do you remember when we found the values of k in direct variation last chapter? This is very similar to this. Here I have this table, and I want to see if this table represents a graph. Now, for example, I'm going to graph something up here. Here's the first point. Here's the second point. Could you find the slope if you wanted to of those 2 points? Here's the third point. Would you say the slope is consistent so far? But let's say this fourth point is right about here. What just happened to the slope? It stopped being consistent, true? So are those 4 points consistent in terms of making a line? Definitely not. But if we found 4 points and all 4 of them had the same slope, would it be a consistent situation? Yeah. And so what I have here is 4 points. And my question are they consistent? So what we're going to do is we're going to try to find the slope very quickly of these 4 points. And I'm going to show you how. So we're going to try to find the change in y over the change in x for each one. So watch with me. What's 6 minus 4? 2. What's 3 minus negative 1? 4. So the slope of those two is 2/4. What's 7 minus 6? 1. What's 5 minus 3? 2. So far, is the slope consistent? So far it is. All right, let's look at the bottom ones. What's 10 minus 7? 3. What's 11 minus 5? Is the slope consistent? Yes. So what can we conclude? What is the slope of all 3? 1/2. Now, that's the hard part. And was that difficult? It's just a practice in finding slope. Now, I didn't do y2 minus y1 in each one. I was doing them consistently. It's important to be consistent, Brett, when you're doing your subtraction. If I do 10 minus 7, give me your eyes. Not to reverse and do 5 minus 11. Always go the same direction. And so long as it's consistent on all of the pairs, you should be in good shape. Now we need to make a choice. Brett, since I'm working with you, Brett, choose. First point, second point, third point, fourth point, it doesn't matter. Third point. So Brett's going to use the third point. So here's my equation. Y minus 7 equals 1/2 times x minus 5. He used the third point. How many other answers are there that are equally correct? 3 other ones, right? Can someone give me one of the other 3 answers? Who can help me? One of the other 3 answers that are correct. Like, who can use the first point? What would it become? What's the y value? Y minus 4 equals 1/2 times x. Instead of minus 1, I have minus a negative 1, so that's plus 1. All right, let's do another one. Someone give me the second equation. Taylor, can you? Good, equals times. Yeah. We're just using the x's and the y's. What about our last one? Some guy. Y minus how much? Nate, what's my y value?
11.
That's x.
Or
10
10.
equals my slope times
X minus 10.
x minus
11.
11. Okay? So any one of those 4 are valid answers. The book's not going to say which one they want you to pick. So you may get this answer, Gabe. The third one, the book might put that answer. if you both have a half, you need to be smart enough to realize, oh, I still have the right answer. Okay? But point slope. So let's look down at the second one. See if it makes sense now. Change in y over change in x. How far from negative 3 down to negative 7? Negative 3 minus negative 7. Can you do that in your head? If you need me to write it out. What is negative 3 minus negative 7? 4. Okay? Bottom one. Negative 1 minus negative 11. 10. Good, Matt. So reduced, that's 2/5. Let's do this next one. Negative 1 minus negative 3. Minus a negative becomes a what? A plus. So negative 1 plus 3 is 2. Then my x is 4 minus negative 1. Minus a minus, once again, is a plus, so that's 2/5. Can I stop? I've got 3 of my points in a line. What about the fourth point? I don't know. Let's do it again. 5 minus negative 1 is 6. 19 minus 4. 15. Divide both by 3. 2/5. So is it consistent? So the first question, if this was on a quiz or a test, Luis, I would say, is the table of data show a consistent linear relationship? And your answer is yes. Now, model that relationship with a graph or with an equation. I'm just going to choose, for sake of it, the third one. So here we go. Y minus a number equals 2/5 times x minus a number. What do I use here? Y minus negative 1 becomes what, Brett? Y plus 1 equals x minus 4. There are 3 other equations just like before. We're not going to write those, but those are my 3 answers. Okay? So, is it consistent? The answer is yes. Thumbs up. If it's consistent, model it with an equation of some sort.